Okay, guys, we're in 2.6. We're looking at other types of equations. The ones that we're really going to look at this time are ones that have what are radical or rational type exponents, radical equations, period. So we're going to look at stuff that have extraneous solutions, which means it may be a solution that you solve for, but it doesn't turn around and satisfy the equation, right? It doesn't work in it. So that's why they call it extraneous. It's an extra solution that just doesn't work. Squaring property of equalities. Basically, if you square one side, you got to square the other, and however extraneous solutions may have been introduced when you do that, right? So just be aware of that. We're going to look at absolute value equations, and what else? Yeah. So here we go. All right, snap, crackle, pop. For the following exercise, solve the rational exponent equation. Use factoring when necessary. Ladies and gentlemen, first things first. I'm going to raise this to the third power. Anybody know why I'm going to raise both sides to the third power? Now, I mean, I could rewrite it. It's the third root of x minus 2 squared, right? Yeah? Because it's got a fractional power. So the denominator is the root, and the top is what the power of the radicand's being raised to. So, but we're just going to get a little crazy with some stuff. So here we go. So x minus 2 to the 2/3 equals 16. All right, guys. Remember the power to a power rule? It means you've got two powers. A power, something raised to a power, raised to another power, you multiply them, right? Yeah. And as long as, this is pretty cool. It doesn't matter what you do to an equation. If you do it to one side, you do it also to the other side, you've got it equal. And it may look whack, cray-cray, but it'll still work. So what I'm going to do is this. 2 times 3 is 6. Divided by 3 is what? 2, right? So it's basically like canceling them out. X minus 2 squared equals, what's 16 cubed? 16 times 16 times 16. How much? No. That's 16 times 3, brother. 4,096. Now I'm going to tell you something. 4,096 happens to be a perfect square. Y'all know that? Yes. Yeah, you're right. I could have done that. Can I work it twice? Okay, good. Well, my brain just went to cancel that, but she's right. We could raise it to the reciprocal of that, and we'll do it. It works a little bit nicer. You're right. Yeah, it's okay. Yeah, we'll go around the world to get there. All right, so I'll finish this one, and then we'll do it like what you'd said. So if I got something squared, how do you get rid of something squared? You take the what? Square root. So I told you 4,096 was a perfect what? Right? So that's plus or minus, what is that? How much? 64? Huh, okay. So, so if I add 2, so x equals 2 plus or minus 64, right? So 2 plus 64 is what? 66 and negative 62. Y'all agree? Yeah? So that's where my brain goes. I normally take care of the denominator first, but you can do it right at reciprocal, and it works out a lot quicker. That's why I love math. And which approach is right? Both. It just depends on what your brain sees. Right? your brain sees that, then you're okay. So let's show you what they're talking about. It may work out a little bit easier. It probably will. That's okay. So x minus, let's do this. X minus 2 raised to the 2/3 equals 16. So if I turn around and raise it to the 3/2, both of them, so snap, crackle, pop. Yeah, okay. It gets down to a little bit quicker. So these cancel out 6/6, so that leaves me x minus 2 equals 16 raised to the 3/2, right? Which is really the square root of 16 cubed, right? Y'all with me? Square root of 16 is what? 4. 4 cubed is what? Thank you. So you get back to here. So we done one extra step, right?
Okay, say that whole process.
Oh, which one? The blue, black, or the other one?
No,
This side? Okay, so if you got a fractional power, you can raise it by its reciprocal, and it'll just cancel it out, right? But you got to do the other side raised to that same power as well. So that's how they get the 3/2 come about. It's the reciprocal of 2/3. All right, so when you do that, this cancels out totally. Leaves you x minus 2. Well, the denominators are 2, right? That's really your root. So the square root of 16 is 4. 4 cubed happens to be 64, right? Or in your calculator, you can take 16 raised to the parentheses 3 divided by 2, close parentheses enter, and it'll give you 64. So your calculator can do that as well. And when you get x minus 2 equals 64, you get the same exact thing as we got in the black and red. Fair enough? Both are correct. Okay. You have to, oh, yes, you have to do plus and minus. You have to do plus and minus on this because it has a power of, or root of, guess what? 2 right there. And that's what you miss that unless you think about it. So, all right. Okay. Lord help me, Jesus. Y'all ready? We can do it in terms of a fancy quadratic, right? Because the linear term's half of the quadratic term, right? Half of half is a fourth, right? So I could do it like a fancy quadratic if I wanted to, and then substitute it back in. Let's see. We can factor out x to the 1/4 if you want to. No? Well, easy depends on the person and whether you understand what I'm doing or not. Okay, we'll factor out x to the 1/4, and then we'll see whether you're like, okay, or you're like, I'm lost. And then I can show you how to rewrite it in terms of a fancy quadratic, and then you could substitute back in. Fair enough? Yeah, okay. Y'all love let me nerd out. Man. Okay. So I can't factor out a number, but I can factor out x to the 1/4. Now that's going to leave me 4x to the what? Minus what? 1 equal to what? 0, right? Y'all agree? Here? What do you mean? Yeah, you said 4. 4's coefficient, right? Or the 1/4 being the power. If I distribute, I have to add my exponents, right? Like bases, multiplied, add their exponents. So fourth of fourth give you a half, right? So that's when I pulled out a fourth. That's really why it became a fourth. Okay. So you've got both of these. You could basically set them equal to 0. So that plus 1, 4x to the 1/4 equals 1. And then we'll divide both sides by 4. Yeah, it kind of gets x to the 1/4 equals 1/4. Now, that's the fourth root, right? Yeah? Man, what's the fourth root of 1/4? Or, let's just do this. No, is it? Let's see. How about this? What's this give me? X equals what? 1, 256. Okay. Y'all agree with that?
I did it differently.
Yeah. Mm-hmm.
I
Yeah.
I just set both of them equal to each other and then raise them both to the fourth.
Really?
And I got 256x.
Yeah. That'd work too. Because what you do to one side, you're doing to the other as well. Yeah. The really cool thing about math is there's always more than one way to solve it. It's truly. Now, did the video show that?
No, I worked that out from 6 or 7 times apart.
Let me show you what she's doing. She said this. She just raised everything to the what? Fourth, which basically said, okay, 4 to the fourth is how much? What's 4 to the fourth? 56, right? And that would be x squared, right? Equals, what's this? X, right? Huh? Uh-uh. That has to be x squared here, right? So, um, well, you basically get this. You take it back over, and you pull out an x, that's 256. X minus 1 equals 0, right? So that still leaves you, when you set this equal to 0, it still leaves you 1 over 256. And this still is x equals what? 0. I mean, it still gets you there, right? Mm-hmm. That's okay. All right, so one of the answers is 256, right? Okay, so now let's look at this other one. This is 1/4, right? So if I raise both sides to the fourth, x equals what? 0. So 0 is one answer, and 1 over 256 is the other. You okay with that? You could do this, but guess what I left out? I mean, I still left with the same thing. We didn't violate any mathematical principles or nothing, which is pretty cool. Here you go. You want, here, I'll do this. I better stop it. All right, guys. Yay. Here's a square root problem. And we're going to solve a square root. And we're going to check for extraneous solutions. So I need you to understand one thing. In order to solve an equation with a radical in it, you must isolate the radical. And if you got two of them, you got to at least isolate one and divide and conquer, right? So to speak. And we're going to have some that have two. But here we go. So the first things first is we're going to take my 4, my negative 4, move it to the other what? Side, right? Guaranteed. So, and then, how do you get rid of a square root? You do what, guys? You square it. Good. What you do one side, you got to do to the other. So it leaves you 2x plus 3 equals what? 16. Now, minus 3. 2x equals 13. Divide both sides by 2. X equals 13 halves, which is nothing more than 6.5, right? Now, does that work? Is that a solution or is it an extraneous solution? How do you know? You better plug it in and check it, right? I love to keep things as fractions. So this becomes what? Huh? Yeah. So that's square root of 16, right? Minus 4 equals 0. So that's 4 minus 4 equals 0. It works, right? That's right.
So define extraneous. Like, how is it? If you put, I'm assuming if you plug it in, that'll be equal. Okay. Then how is it a solution? To get that part. Why is that a solution? Or is it like an accident?
If both sides of an equation are squared, the solutions to the new equations are solutions to the original equation. However, extraneous solutions may have been introduced.
Okay.
That's why. You know, extraneous are solutions that satisfy a manipulated equation but do not satisfy the original equation, right? So that's how you know. So, and it satisfied it, so therefore it's not an extraneous solution, right? So, y'all good? Yeah. Okay. Bear with me. All right. So what would you do here? I hate y's and not change these to x's, just because I live in a world of x, right? So x plus 3 equals 3x plus. All right. There you go. Right. So what's the first thing you're gonna do? What's the first thing you want to do? Yeah. You got to get rid of that radical, right? So it's square root, so I'm going to square. Look right there. What when I square the left-hand side, what have I really created now? Uh-uh. We came across this when we were looking at completing a square. This is what we created. You remember what we created? When you have a trinomial that the factors are the same, that can be rewritten as a binomial squared, right? That's called a perfect square trinomial, right? So what we've created is a perfect square trinomial. So that's going to be really x plus 3 and x plus 3, right? Equals 3x plus 7. And guess what you're going to get? Nice little quadratic, right? So you can split it and multiply it, right? So that's x squared plus 3x plus 3x plus 9 equals 3x plus 7. I'm going to show you something. I'll show you, I hate to say shortcut, but it's more of understanding than anything. So x squared plus 6x plus 9 equals 3x plus 7. And then let's go here. I'm just going to take all of this over at one time. So that's x squared plus 3x plus 2 equals 0. So how do we solve that quadratic? We could factor it. Yes, we could. We could also do what? What works 100% of the time? Quadratic formula and complete square works too, because we have a coefficient of 1, right? But you don't want to take half of 3 right? All that stuff. Nah. So yeah, it's factorable, right? So what are factors of 2 when added together give you 3? That's this, right? So we have x plus 1 and x plus what? Equals 0. And then let's see. Yeah, x plus 1 equals 0, x plus 2 equals 0. So x equals -1 and x equals -2. Fair enough? Now, I want to show you a really cool thing. And I'm going to show you how to go from the red to the purple. Pretty easy. So we're going to take out the black, the blue, and go to the purple. Okay? So when you do a perfect squared trinomial, what you have to understand is most people go, okay, well, that's x squared and 3 squared, right? Y'all agree? But you come across, y'all remember, if I can think about this. This may jog your brain. Y'all remember that? Remember when you had to expand perfect square trinomials with an addition, perfect square with negatives, and then perfect cubes, all that stuff? You all remember that? This is more polynomial theory, right? No? All right. Well, this is really what I'm about to show you, right? So a squared, most people go a squared and b squared, right? And you get the outsides. But here's what I want to show you. A times b times who? A times b times 2. Watch this. It makes life a lot easier. And this is why we can do it. So we got x squared, right? That's there. We got 3 squared. That's the 9. What's 3 times x? Times 2? 6x. So that's how you can expand or multiply a perfect square trinomial with the math behind it to do that, right? That's why that works. It'll work like that all the times. But the most common mistake is people just square the x and square the 3, and then that's it. No, you're living off the 2ab, right? The 2 times the x and the 3. So just be, it can speed up things if you want to. The more you know, the smarter you're going to work. It's okay. It's okay. No harm, no foul. Right? Just food for thought. Okay. Did we solve it? Yeah, we did. What did we say it was? -1, -2, right? Right. Yeah, y'all good? Yeah. Yeah. Hey, where can you see this again?
On the website.
Yeah. You can spend another night with us again. All right. That's cool. You know, if you're bored and Netflix ain't coming through for you or anything like that, you can always do that. So, okay. Yeah, this right here, guaranteed to use a half page of paper. Guaranteed. And it's the one that's going to be like, you get all the way down to the end, you're like, because you made one simple mistake and it's like cray cray. And I hate Y's. So we're using X, okay? So here we go. All right. Now, you heard me earlier say, okay, how do you solve a radical type equation? Well, you isolate the radical. Well, what happens if you have 2 of them? Well, you're going to do the process twice. So you take one of them and isolate it. So do I have one isolated? Most certainly I do. So here I go. Now, the right side becomes a piece of cake. That's just x plus 8, right? Now, the left side of this is where you want to use that perfect square trinomial expansion because it's going to save your life. Do you understand what I'm talking about? The a squared plus 2ab plus b squared, right? Yes. So, huh? What? This is a binomial. Oh. Yeah, I got two things I'm squaring here, right? Now, if it was just this, take the one away, man, we could rock and roll all day long. But we can't do that. You know why?
It wouldn't just be x plus 1 plus 2 or plus 1 plus 2.
Yeah.
It wouldn't be, or was that enough?
That's enough.
You can't do that.
That's right. That's right. Gotta make sure I'm on. I'm on. Good. Okay. So, here's where we're going. Gotta make sure everybody's with me. Trust the math. It is your friend. Yeah. Yeah, it is. So, a plus b squared equals a squared plus 2ab plus b squared, right? That's what we're going to hang our hats on, right? Yeah? Okay, so. Oh, man. Okay, so let's square the first one. What happens when we square the square root of x minus 1? It just gives me what? X minus 1, right? Let's square the last one. Well, the b part is 1, right? So that would be just squaring 1 is what? Plus 1. Okay, now, let's take the a and the b and multiply them together. Well, that's the square root of x minus 1 times what? 1 times what? 2. Ah, shoot. He got happy because we were about to do some math. That's what you're going to be left with. Now, it's because of this trinomial, polynomial theories stuff right there, right? Expanding them, perfect squares, trinomials, all that stuff. Or you can just do it like this, guys. There you go. You can multiply those two together, and guess what you're going to get? Now, look what happens. That one and that one does what? Good. So that's going to leave me with, well, those go away. Now, let's move the x and the 8 to the other side. You want to do that too? Yeah, let's do that. Or do we? No, we don't want to do that. Hold up. Let's don't do that. Oh, where you at? Okay, so I ain't gonna do 2 and 1. I'll just stop. The negative 1 and positive 1 cancel out, right? Y'all okay? All right, so that's what I've got so far. Y'all good? Good? Okay, so I'm gonna move I need to isolate my radical, right? So I'm just gonna move it to the other what? So what happened to my x's? They went what? Away. Went away, that's right. I know. My brain went there too. Okay, so it leaves me with 8 on the other side. Man, do y'all see how easy this math is coming apart? Okay, so so that's going to leave me with x minus 1. The square root of x minus 1 equals 4, right? Y'all okay with that? All right. How you get rid of a square root? Square it. What you do to one side, you do to the what? So I got x minus 1 equals what? 16. So, ladies and gentlemen, add 1. X is what? Man. Boom. Now, does that work? Yeah, that works because you got 5 equal to 5, right? When you plug that in. 17 minus 1 is 16 squared. 16 is 4. 4 plus 1 is 5. And 17 plus 8 is 25. Square root of 25 is 5. Sure can. Sure can. Now, I'm going to tell you something. The only way you get good at these is if you practice. You understand? And just as sure as God made little green apples, I guarantee that's probably going to be on the test. Because I'd put one on there. You know why? Because that's going to separate the haves from the have-nots, right? Those that can and those that can't. I mean, it's going to be a meat and tater type question. I'd put that on there. Now, I haven't looked at your test because I don't make it up. Because this whole course was copied from a master file. So, Homesmith made this one. But I'm just telling you. If I had to, yeah, that right there would be on there. So I'd make sure I knew how to do that, right? Don't let the polynomial theory mess you up over there. You got to make sure you're solid with stuff like that. Okay? The only way you get solid with that is if you practice it, if you do it. Even if you get it right, can you do another one? Yeah? And it still keep it right, correct? Yeah. I mean, once you get it right, yay, right? So your high score is always kept. You always get in practice. And you should be able to always get in the practice after your homework's closed, right? It just won't change your score, right? Right? Yeah, up means back up to the top, or okay. Just pick one, it don't matter. Fill it in. Got it? All right. Y'all ready? I know you're saturated. It's okay. But remember, you signed up for an 8-week class. So, I know. I'm with you. That's why we're doing the videos, right? That's why we're doing the videos. We're here to help you, not hurt you, right? Yeah. Ah. Well, I'm here to make sure you can do it, right? And I'm going to show you the best ways to approach it. I'm going to teach you how to think about things a little bit different, right? Okay, guys, we're getting into absolute values, right? Absolute values. Now, you got to understand one thing about absolute values, period. You have two answers, right? If I said, what gives me 5 from an absolute value standpoint? Well, it is what? 5 and what? But why is it that why does an absolute value always return a positive? It is exactly right. She's exactly right. It's the distance from that point back to 0. And distance, ladies and gentlemen, can never, ever be negative, period. You're not negative 5'11" tall. Go into Home Depot, do this. Go into Home Depot, say, hey, dude, I need a 2x4, negative 8 feet long. I guarantee you they'll call security on you. Yep, they will. And they'll look at you strange. Yeah. Just do it for grins and giggles. So, all right. So we're going to have a positive equation and a negative equation. All right. So I'm going to teach you how to write both. And in doing so, to get the negative, you're basically dividing both sides by -1, right? Which only changes your right side of your equation. So this is what I mean by that. So, all right, you ready? So I'm going to write the positive, and make that go down. I'm going to write the positive and the negative, okay? And if you do this, you'll be less likely to make a mistake. The positive is exactly what's written there without the absolute values. So we're going to write 9y plus 3 equals negative what? 9. Okay? Now, my negative equation means that I'm going to multiply the right side of that equation by negative 1. So in doing that, I have the same thing in the absolute values, but my right side is negative 9. Now it becomes, guess what? A positive 9. Because the negative times the negative is a positive. Now, ladies and gentlemen, solve the equations, and you're done. You have 2 solutions. Yeah.
Why do you multiply the right side? What's the reason behind that?
Negative 5 would return a positive 5, right? You're basically doing this. Some number, and then this, right? Some number. And because of the negative, it's easier, instead of having to multiply everything underneath the radical, or not the radical, inside the absolute value by the negative, you just multiply the right side by the negative and you're good. It's kind of like what happens when you have negative x equals 1. You just change the sign of the right side, right? And just put x equals that. So that's really what you're doing. So, all right, so here we go. So that's negative 3. So that's 9y equals negative 12. Divide both sides by 9. And we get y equals 4/3, negative 4/3, right? So I simplify that. Yep. And then let's do the other side. So that's 9y equals what? 6. Divide both sides by 9. So y equals 2/3. Right? Okay. Now, it's an and. It's compound inequality, right? It is negative 4/3 and guess what? 2/3, right? It's both of those. Because both of those satisfy the absolute value equation. Questions? 9. Negative 4/3 and 2/3. It should have something allow you to be able to. It may have you put negative 4/3, comma 2/3, right? Whatever, you know. Sometimes they allow you to do answers like that. Have you worked this one? So it puts a comma. You put a comma. She's already worked it. Yeah. Okay. All right. So I'm gonna pause. I'm gonna give you a head start. I'm gonna give you a 45-second running head start to work this one. Okay. Because I need you to be solid on this. Did you write your positive and negative? Yeah. Your positive come out and look like this. It's exactly like it, right? And then the negative is the absolute value with the right side being multiplied by negative, right? And in doing that, it left me with the 5 being a negative 5, right? So negative 2y equals 2. Of course, that's y equals negative 1, right? And then I'll do this one. And I got y equals 4, right? How do we do? Good? So how would I write my answer? I'd go negative 1, comma 4, right? All right. No good? Sweet. Sir? It shouldn't, because it should be, I don't think it's string comparator. It should be value comparators. Should be. Oh, man. Okay. What you want to do first? Do what now? I'm going to clear my fraction too. Now, do we have a... We do? All right. Yeah. Do we have a value for x that wouldn't work? 0. Yeah, we have an x in the denominator, so therefore we have what? Can't even think of the term. Huh? Yeah, basically x values that would make it undefined, right? Restrictions. Duh. Okay, restrictions. Okay, so we'll multiply both sides by what? X. You want 2x? See, that's going to take it all, right? Correct? Is that okay? Yeah? Because we get rid of that fraction. If we're getting rid of fraction, I might just get rid of all of it. So when we do that, that's going to give me 2x squared minus 4 equals minus 2x, right? Ladies and gentlemen, what is that? That there be a quadratic, right? Mm-hmm. Yep. So we're going to get everything on one side and say it equals 0. You okay with that? Any questions about that? How do you want to solve this? You want to do factoring? Huh? Oh, you want to? All right, we can do that too, right? We just divide both sides by 2, right? Yeah, so that's x squared plus 1x, right? Minus 2 equals 0, right? Oh, snap. Okay. So what are values when multiplied give you -2, but add together to give you a +1? How about 2 and -1? You okay with that? And then with this, we're going to go right on here, right? And we're going to have x plus 2 and x minus 1. That's all set equal to 0. So we'll set each independent factor equal to 0. So x equals -2 and x equals what? 1. Now, is any of those a restricted value? Something x cannot be equal to? Anything? No? Okay. Hey, that TI-36X Pro that I told y'all you need to get, right? That's like 18 bucks. Yeah, you go Polysolve, quadratic. Hello, type that in. Polysolve. 2x squared plus 2x minus 4. Boom. Hit solve and you're done. It'll do it for you. It doesn't matter what it is. It's wonderful. You see it? Uh-huh. Yeah, hit enter. And it'll ask you what A, B, and C are. And you hit enter again to solve it. And then you're done. It should give you -2 and 1, right? Yeah. If you got an 83 or 84, you could graph that and find out where it intersects the x-axis. That'd be solutions as well. You can do that. Multiple things. Did you get it? You get it? Oh, I have to show you that. Before you go, come see me. All right. All right. Oh, snap. Y'all know that little thing we just done right over there? That's what we're going to do. It's called a fancy quadratic. It's fancy. It's really crazy. But I told you set g equal to the linear term, right? All right. There you go. So, if I say that's g, then this becomes what? G squared minus 6g plus 5 equal to what? See, now that looks much prettier than having to do all that other stuff, right? Now we'll factor it and solve it, and then we'll turn around and plug in what g is, and then finish really solving it, right? So that's really what we're doing. Yeah.
Is there a different way to do this, or is this the only way?
Well, that's the only way I know. Yeah, seriously, that's the only way I know.
The g is thrown. I don't understand what is g.
G's just a variable I picked. You had 26 to choose from.
Yeah. What's the point of it though? That's what I'm not getting.
It allows you to take it's a quadratic. You agree? The middle term is half the power of the first one, right? So that by definition is a quadratic. And they call it fancy quadratics if you have like 10th and 5 and 6 and 3 and 8 and 4, right? Higher powers are normally what you see it. But you can have binomials in there.
Okay.
And the only way you can really deal with them is if to use the substitution, a fancy quadratic. So here we go. So are there factors of 5 when added together give you negative 6? Well, of course they are. Negative 1 and negative what? See, if this B down here is negative, but your A times C is positive, then you know you got two negatives, right? It's got to be like that. So basically what we have, G minus 1 and then G minus 5, right? All equal to 0? Yes? So I'm going to set it equal to 0 and at least get the number to the other side before solving. So hang with me. G minus 1 equals 0, and then I'll do G minus 5 equals 0. Let's take the first one first. So I'm going to add, G equals 1, right? Well, what did we say G was equal to, really? There you go. Now how easy that is? Now just finish solving that. Ladies and gentlemen, A equals 5/3, right? And then, of course, this one, plus 5. G equals 5. And then I go 3A minus 4 equals 5. So that's plus 4. 3A equals 9. Ladies and gentlemen, A equals what? 3. That's about the only way to do that. Okay? And it works pretty good. It really does. Any questions? This approach, this technique, you need to work a couple of them doing this for it to go, oh, okay. Now, and that's like something you put in your tool belt, right? We've seen it already one time tonight, right? Yeah. I used it on that thing over there. It's a good little technique. It's an algebraic technique. So that's really what college algebra is teaching you, algebraic techniques to solve things, right? Yeah. Oh, yeah. Yeah. Well, I kind of think of it like this. If you miss it, you have less tools in your tool belt to do the job. That's exactly right. Know what you know what you don't know, and get your unknowns known. All right. I put it on here. You know why I put it on here? Because I wanted to see if you could do it. You want to do it? Yeah? All right, I'm going to give you a running head start on this. Okay, guys, here we go. So I'm going to say G is equal to 2A minus 2. So if I do that, that gives me 2G squared plus 7G plus 5 equal to 0. So it ought to be factorable, right? What multiplies to give me 10, adds together to give me 7, right? What's 2 and 5? Now, I taught you the other day, and I said, guys, normally, hold up, friends. Oh, A times C. A times C. Every time you go to factor a quadratic, it's always A times C. What multiplies to give you A times C. But see, A is normally 1, right? And we normally don't have anything to worry about. But when it's something other than 1, we forget that. If you go out and look on our notes prior to this, we wrote down A times C. But you remember the other day when it was talking about, okay, hey, you can factor out the 2 here, right? And then do some things. Or you can divide out well, really, division and factor is the same thing. But you can divide it out at the end, right? Y'all remember that? So watch what I'm about to do. This is very important. So watch what I'm about to do. Note that I put the 2, the coefficient of a, the quadratic term, in both of these. Because what I'm going to do is I'm going to divide it out of both of them. See, you either divide it in the front or you can do it in the rear. It doesn't matter. Doesn't matter. So 2g plus 2 equals 0. And then 2g plus 5 equals 0. And of course, this is going to give you 2g equals negative 2. And of course, g equals negative 1. But I'm not done, am I? No, because what's g? 2a minus 2. So now I'm going to do 2a minus 2 equals negative 1. And that's going to give me a plus 2. So that's 2a equals 1. A equals 1 half, right? Did you get 1 half? Sweet. Okay. And now let's do it over here. I'm going to minus 5. 2g equals negative 5. So g equals negative 5 halves. And we know that g is what? 2a minus 2 equals negative 5 halves. Huh? Multiply it, distribute the 2, and just keep it. Because I'd done the 2 over here, and it was nice and pretty. Oh, it'll be okay. Isn't it really the same?
Well, I mean, technically, yes, but multiplication is better.
Keep, change, flip, right? And you change it from division to multiplication, right? So, yeah. Okay. So, hey, I'm going to do exactly what I got right here. Yeah, because it's not that bad, guys. Really, it's not. It's worse. I got to add fractions, right? Okay. What fraction with a denominator of 2, when simplified, will give me a 2? 4 over what? 4 halves. So, guys, listen. 4 halves minus 5 halves is what? Negative 1 half, right? Yeah? Y'all see how I've done that? I just rewrote 2 as 4 over 2. Substitute in because 2 is denominator. Yeah? Man, I could so rock elementary right now. Just like, I wasn't that good in elementary at all. Those fraction things, yeah. This wasn't good. Okay. My brain just doesn't do this. Sorry. Y'all good with that? Do y'all see what I've done right here? I can't take my brain. Look, maybe your brain does. But you would think my brain, as mathematical as it is, can figure that out, right? It ain't going there. So when I have a fraction divided by something, or something divided by fraction, then I'm going to write it out just like that. And do my keep, change, what? Opposite. Because I know that that is a viable solution for me. And then when I get done, I know that I know that I know what I done was right. I ain't got to worry about it. So, yeah. Okay. Well, any questions? How'd you do? We get the same? Yeah? Sweet. Anybody crash and burn? Yeah? Did you find your mistake? No? Okay. Don't give up. This is pretty cool. Okay? All right, let's do another. Let's see what else they got us. Oh, my. Man. Okay.
The radical first.
Well, it's got a radical in it. So what are we going to do first, guys? Isolate the radical, right? That's our game plan, right? If you got a radical, we got to isolate it. Right? So, what if I took that negative 5 square root of 3x plus 4 over to the other side? Would it change to a positive 5? Yes or no?
Say that one more time.
If if I took the negative 5 times square root of 3x plus 4 and move it to the other side, would it change it from a negative to a positive?
Yeah.
Yes or no?
Yes.
No. Listen, you would know the answer to this if this was just 5x, right? If it's a negative 5x, I said move to the other side, it'd be a positive what? 5x. Okay, so you got to use that same thing. So if I take my radical to the other side, it's got a coefficient in front of it, right? Okay, so if it's a negative, I move to the other side. Laws of moving things are positives or what? Next addition or subtraction, right? So don't let that get you. If I move that to the other side, then I can kind of clear up or clean up the left-hand side, right? Yeah, I can. Well, let's do it. I mean, ain't no reason for me to sit here and waste nerding out. Let's just do it. Okay, that's what I got so far. Then I got 3x plus 10 equals 5. 3x plus 4, right? What are you going to do? We could square both sides right now if we wanted to, right? Why? Well, if I divide the 10 by 5, that's not a problem. But do you see that 3/5 over there? Do you really want to expand that binomial with a 3/5 in the coefficient of x? Nah, I don't want to. And neither should you. So, no, if it didn't go into it all the way, say, look, divide 5, but that's good. It's great right there, but look right here. No. So let's keep 5 over there. So how are we going to do that? Say. You ready? Shoot, yeah, we're going to square both sides. Because we got to get rid of that radical, right? Yeah. See? This beats any English class ever. Period. Hands down. All right. You want to expand this like that polynomial? You want to do that? It's a perfect square. You want to do it? Yeah, let's do it. What's 3x squared? 3x squared. Yeah, it's 9x what? What's 10 squared? 100. What's 3x times 10? 3x times 10. No. 10. Them different from 100. All right, so what's 3x times 10? What's a times b? 3x times 10 is 30x, right? Times the 2 is what? 60x there. So we multiplied that, right? Can you write that twice and expand it? You most certainly can. Knock yourself out. You can do this right here. There you go. You can multiply them there two binomials together. And when you get done, you get this right here. Agree, disagree? Agree. Thank you. Now, when we square that radical, it's going to go away, right? Y'all agree? But what happens to that 5? Does it?
I don't think so.
Does it? Yeah, it does. Has to, right? So, ladies and gentlemen, that leaves you with this. Right? No. It's worse. I do that. I listen, dude. I'm not gonna lie to you. I mean I'm cringing because that's some big numbers. All right. All right, here we go. We're going to distribute that. That's 75x plus 100 equals 9x squared plus 60x plus 100. Now, what's going to happen is I didn't preview this one, which means I didn't go and work out some of the problems ahead of time. And that's going to catch me one night. And when it does, it'll be okay. I'll go, sorry. And I'll just take it off of your homework. And we'll just keep on going. Fair enough? Because if I draw a blank on it, guess what? No. No. I'll just take it off. I'll make that bet. How's that? If I draw a blank on something, then there you go. But what do you think the chances of me drawing a blank are?
I've seen you do it.
I have done it. It happens. Rarely, but it does happen. I got that. What'd you get? Now, you got a quadratic term, you got a linear term. How you going to solve that? It's an easy way to do it. It's a 3-letter acronym. Got an F in it. And it ain't W. It's a G. GCF, right? Greatest common factor. You got a quadratic term and linear term. You can solve it by doing the greatest common factor. So what's the greatest common factor between 9 and 15? 3. Good. And I guarantee I'll take an X, right? So therefore, that leaves me at 3x squared minus 5 equals 0. So I have two factors, right? 3x equals 0, so x equals 0. Guaranteed. Anytime you have a quadratic term, a linear term, yeah.
Yeah, it wouldn't be complex.
Oh, yeah, sorry. I rewrote something bad. Thank you for the catch. So anytime you have a quadratic term, linear term, guaranteed one of your roots, your solution, is going to be a 0. Guaranteed. You can bet on it. Oh, yeah, we are. Yeah. Oh, yeah, we're about done. We're done right there. Anytime you have a quadratic term and a linear term, period. That's the only thing you got there. You could do this, solve it by GCF, which means pull out the greatest common factor, which can be a number, a variable, or a product of a number and variable, right? But it's guaranteed to at least be a variable on these because you have an x squared and an x, right? So you can at least pull out a variable. Now the question is, can I also pull out a number too? That's the what if. But always, one of your solutions will always be 0, guaranteed. Yes?
So, 0, you got rid of your 3x.
Yeah, so divide both sides by 3, right? Yeah, 0 divided by 3 is 0, right? And I got x equals 5/3, right? Yeah? Okay? Y'all like it? It wasn't as bad as we thought. Hold up, where are we going? Wait, we got that one, that one. Oh, snap, that one. Oh, we got 3 more left, right? Okay. All right. Well, that's all the time we have for tonight. We thank you for attending. We shall see you again on what day? Monday. If you have any homework questions or any other things you want to talk to, come see me. We'll be up here all night. So we're looking at this polynomial and it asks us to solve it by grouping and factoring. So what we're going to do is this. We're going to group it. And when we group it, you're looking at trying to factor out a GCF. Okay? You factor out a GCF. So the GCF of the first parentheses would be 3x squared, right? All right, so I'm factoring out 3x squared. I have x minus 3, right? So what I want to do is create a the other. Okay, this thing's going beep, 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 and I don't know why it's going beep, 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 other than maybe it's about to die. So, huh? Is it? That's a, so, let's look at this. Oh, no. All right. So what do I need to do to negative 3x to get just x? I need to do what? Take out a negative 3, right? And I want to do that. That leaves me with this. This is all set equal to 0. So if you remember factoring by grouping, the parentheses become one parentheses, and everything on the outside becomes another set. Okay. So we're going to set each one of these equal to 0. So I will add 3 here. So that's 3x squared equal to 3. And then I've got divide by 3. So I got x squared equal to 1. And of course, guys, we'll take square root. So x equals plus minus 1 there. We'll come over here and we'll add 3 to both sides. So x equals 3. So we basically have 1 or negative 1, 1, and 3. Right? It's a third degree polynomial, so therefore it should have 3 roots, right? Up to 3 roots possible, right? So, any questions on that one? Y'all good? Factor that, give me an x squared, then just 1, and then square root of both sides, plus minus. All right. So let's look at this one. We're not going to do anything different to this one other than the same that we did before. So we're going to factor we're going to GCF this, and we're going to factor a 3x cubed out of it. So that leaves me with x squared minus 5, right, equals 0. All right, so in doing that, we have 3x cubed equals 0, right? And x squared minus 5 equals 0. Both of these are factors, are they not? All right, so divide by 3. So x cubed equals 0. Take the cube root. Folks, 0 is a root, right? All right, so now we just got to worry about this other side over here. Add 5 to both sides. X squared equals 5. And then we'll take the square root of both sides. And then x equals plus minus square root of 5, right? So they're looking for 3 answers. Even though it's a 5th degree polynomial, when you're looking at this, there's only going to have 3 roots. Okay. So we have negative square root of 5, 0, and square root of 5, right? Oh, sorry. Sorry. Yeah, I don't know. Okay, any questions about that one? That one's pretty straightforward. I hate to say it's straightforward, but these two solve the same. All right, they solve the same. So, let's look at the next one. For the following exercise, use the model for body surface area, BSA, such that the BSA equals the square root of WH divided by 3,600, where W is weight in kilograms and H is height in centimeters. Find the height of a 46 kilogram female to the nearest centimeter whose BSA is 1.4. So basically all we're going to do is plug things in, right? 1.4 equals the square root of weighs 46 kilograms times H over 3,600, right? Well, if you're looking at this, the first thing that we need to do is what, guys? Huh? Yeah, get rid of square root because we got to get in there to that H, right? So how do you get rid of a square root? You square it. What you do to one side, you do to the other. So, not sure what 1.4 squared is, but yep. So I got 1.96 equals 46H divided by 3,600, right? Now, so we need to, we can do a couple of things here. See if you can follow what I'm about to do, and we'll talk about this. Did you see what I did there? If I multiply both sides by 3,600, then that takes 3,600, puts it up top times 1.96, right? And gets rid of that. Then divide both sides by 46, correct? So it cancels on the right side. Yeah? So I'm just kind of manipulating some things. You know, if things are diagonally, they can switch places, right? Y'all remember that? We talked about that one night. So if they're diagonally going left to right or right to left, they can go there. So what is 1.96 times 3,600 divided by 46? Height equals 153.39 centimeters, right?